Alright, how you guys doing today? This is Mr. Muscarella coming at you, and we are going to take a look at finding the center, foci, vertices, and co-vertices for an ellipse. Alright, so we've got our two equations here for ellipses, and both of these equations, the a squared and b squared, are in different spots. The rest of it, it's all the same. So what that's going to tell me when I take a look for the a squared, most textbooks, the a squared is going to be the larger of the two numbers between a squared and b squared. What a squared tells me is the direction that the ellipse is going to be shaped. So if I have an ellipse that has a squared underneath the x part, then that means that the ellipse is going to be shaped kind of like this. And what I'm drawing on there is the major axis. So the major axis is actually going to be parallel to the x-axis. And the way I like to remember this, the bigger number between a squared and b squared is going to be underneath the x's, so it's going to be, our ellipse is going to be stretched horizontally. It's going to be parallel to the x-axis. Now, a couple of things about this. Both equations they get after finding the center of our ellipse the same way. They just look at the h and k coordinates and they just pluck that, and it's like, all right, there's our center. So whether we're dealing with an ellipse that is stretched horizontally or one that's stretched vertically, you still get the center from the same way. Now the foci and vertices, those two things, they come off of the major axis. To find the foci and find the vertices, I know we've got some formulas right here, but I want to think about this from a common sense kind of perspective. My vertices are going to be located on the ends of my ellipse on the major axis. So one is going to be located right here on the left side, and one's going to be located right here on the right side for this particular ellipse. Now to find the coordinates for that, I'm going to usually be told a couple of things, but all I need to do is just square root whatever a squared is. When I square root that, that'll tell me how far to the left and how far to the right that I go from the center. Same idea for the foci. When I go to find the foci, I'll use an equation, usually this one down here, the c squared equals a squared minus b squared, and that is going to have a location right there and another location right there, and that'll be where the foci are located, generally speaking. Now to find each of these, we've got all these little formulas here and a couple of equations that can help us determine where those are located, but what I want you to pay attention to is just where the major axis is. The major axis is going to contain the center, the foci, and the vertices. So that's going to be a critical piece that we'll have to make sure that we pay attention to when we look at an ellipse. Now, even though sometimes we have to find these other things, looking at it from a graphical perspective is just going to help us make sense of what's going on from a graphical perspective. Now, if my ellipse was the other way around, where a squared is underneath the y minus k squared part, so if the bigger number is underneath the y squared piece, my major axis this time is going to go vertically. So since that's going to be vertical, then I'm going to deal with the same kind of stuff. My vertices are going to be at the top and the bottom of that major axis, and then my foci are going to be somewhere else along that major axis, but they're not going to be quite as far as the vertices. Now both the vertices and the foci, both of those are equidistant from the center. So what that means is that if the distance from here to here is 2, then the distance from here to here is 2. So nothing changes there. They're going to be equidistant. And then same thing for my vertices. If from here all the way to the center, if that distance is say 4, then the distance from the center to the other vertice is also 4, which means my major axis has a length of 8. The other small thing I want you to pay attention to is just kind of a common sense thing here with this. If I take a look at the ellipse on the left, this horizontal line right here, if you were to kind of give me a general equation for that line, it would be y equals and then some number. Now that's going to be parallel to the x-axis, but y equals some number. So if I look at the coordinates for both the center, the foci, and even the vertices, notice your y values are all going to be the same. Okay, and they're going to be exactly the same no matter what. Similarly, if I look at my other type of ellipse where the bigger number between a squared and b squared is underneath the y squared part, notice here your center, your foci, and your vertices. All of those have the same starting spot. So they're all going to start at x equals and then some number. Because this particular ellipse is all going to start the same with each of those pieces being the same way. Where I do my shifting is above or below my y coordinate for the center. So that's what the k plus or minus c or the k plus or minus a means. And to get a or to get b, I simply look at the a squared and b squared numbers and I'll square root those. To find c squared, we'll just use our equation that looks a little bit like Pythagorean theorem, but it's not. So just be really careful on that. All of this will become a little bit more clear as we take a look at our first example. Now, if I take a look at my equation here, it's not set equal to 1. So that's the first thing that I have to do. So I'm going to divide everything by 18. And then that will help me get things started. So 9 over 18, that's going to reduce to 1/2. So I'm going to have x minus 3, that whole quantity squared, over 2 plus, and then y plus 2 squared over 18 equals 1. So this will give me my standard form for my ellipse. Now from here, it's really nice because I can tell now what my center is. So my center has coordinates 3, -2. Now what I like to do is I always kind of like to take a look at things from a graphical perspective. So I'm going to go ahead and plot 3, -2. So 3, -2. I'm going to plot that, and that's going to help me with a couple of things coming up. Now if I look at the numbers 2 and 18, common sense question, we're going to ask it anyway. Which one of those is bigger? The 18 is. So what that tells me is that my ellipse is going to be shaped kind of like this. All right, it's going to be stretched vertically compared to one where it would be like this, where my ellipse will be shaped like that. So I know that going into the problem that my ellipse is going to kind of be shaped like this, which means that my major axis is going to go right along here, and my minor axis is going to go along this way, because my vertices, remember, those are along your major axis. And the co-vertices, they're along the minor axis. And the foci, they're also on the major axis. So that major axis is going to help me out quite a bit. All right, so more on that in a little bit. Now let's kind of get after each one of those pieces. Now for the vertices, to find those, what I'm going to do is look at the 18, and I have to take the square root of that. In our textbook, I think most of them will kind of use the bigger number in the denominator as the value of a squared. So to figure out a, I'm just going to take the square root of 18. You have square root of 9, square root of 2. Simplified all the way down, a is going to have a value of 3 square roots of 2. But I want to go back to square root of 18 for a second. That's kind of close to the square root of 16, and I know that that would be 4. Since it's square root of 18, that's just a little bit more than 4. So what I'm going to do then is go 4 units above my center, so 1, 2, 3, 4, and a little bit more than that. And then 1, 2, 3, 4 down, and a little bit more than that, because square root of 18 is just going to be a little bit more than square root of 16. So that gives me my vertices. Now, writing the coordinates for that is going to just not be a big deal, but I want to take my time. I'm going to give the exact value. And the exact value for my vertices, so my x-coordinate was the same thing as what the x-coordinate was for my center, which is this 3. And then I started at -2 and I went up 3 square roots of 2. And then for my other one, again, I started at 3, but then I went to -2 and went down 3 square roots of 2. So those are the two coordinates an exact value for my vertices. Now for my co-vertices, there I'm going to work with the 2, in this case b squared. So if b squared is 2, that means b is just going to be the square root of 2. So b has a value of square root of 2. So I'm going to go, now square root of 2 is a little bit more than 1, or less than 2. So I'm going to go from my center, I'm going to go a little bit more than 1 to the right, and a little bit more than 1 to the left. So that's where my co-vertices are. So for my co-vertices, I'm going to start from the same x-coordinate, but I'm going to go left and right square root of 2. So I'll go 3 plus the square root of 2, but my y-coordinate is going to be the same thing as my center, which is -2. And then I'm going to go 3 minus the square root of 2, because that moves me to the left, but again, my y coordinate will be the same. So those are the exact coordinates for my co-vertices. Now, in order to find the foci, my foci, remember, they're going to be somewhere, and I don't really quite know where, but they're going to be somewhere on my major axis. They're going to be somewhere on that line right there. And I don't know where, but to do that, I'm going to need to find the value of c. And to do that, we've got a nice little equation. C squared is going to be equal to a squared minus b squared. Now, to solve this, I'm really just going to simply substitute in a squared, I know that's 18, and b squared, I know that's 2. So here comes the really tough part. 18 minus 2 gives me 16. We end up solving for c, and we get plus or minus 4. So what that's going to tell me is that from my center, I'm going to move 4 units up. So 1, 2, 3, 4. That's going to put me right there. Oh, I like that. Nice, even coordinate. Nice whole number integer coordinate. Now you move 4 down. So then when I go to write the coordinates for my foci, that's really easy to do because I landed on integers. So one of them is at 3, 2, and my other foci is at 3, -6. Well, that wasn't so bad. All right, so here we go with our next example. Check this one out. It's got to find the same stuff, but this time it's not really in the form that we would like it to be. So in order to get this started, what I'm going to do is go ahead and regroup my terms so that I keep my x's together and my y's together. And giving you a heads up, we're going to have to use completing the square. Yeah. So let's check it out. We'll have 4x squareds plus my 8x. So I'm going to rewrite those together. And then plus my 3y squared. And then minus 6y equals 5. So I'm going to kind of do that. Next thing I'm going to do is I'm going to factor out from my x terms, I'm going to factor out a 4. I'm going to have x squared plus 2x. And I'm going to put a plus and then a blank right there. And we'll come back to that in a moment. Then for the y terms, what I'm going to do is factor out a 3 from there, in which case I'll have 3 and then parentheses y squared minus 2y. And again, I'm going to put a plus and then a little blank, and equals 5. Now, since I put 2 blanks on the left side, I'm going to add 2 blanks on the right side. Now, in order to get this to be, each one of these to be a perfect square trinomial, what we're going to do is first, I'm going to take a look at the linear term for the x's. What is half of 2? Well, half of 2 is 1. Okay, so if I do half of 2, come up with 1, then I square that value. 1 squared is just 1. Now we'll look at the linear term for my y's, and I kind of go through that same process. I'll take half of -2, which is, again, -1. When I square -1, I still get 1. Now here's where you have to be careful. The numbers we're going to add on the other side aren't 1 and 1. When I take a look at the first one, I've got to take 4 and multiply it by 1. So 4 times 1 is 4. Now I'm going to do the same thing here. 3 times 1 is 3. So that's a common mistake people will make when they use complete the square. They'll forget to add the correct numbers on the other side when you have a constant out in front of your perfect square trinomial. Now when I rewrite this, I'm going to get 4 and then x plus 1, that whole quantity squared, plus 3 times y minus 1 quantity squared equals 12. So I end up with this equation here. Now it's not set equal to 1, so I have to divide every single thing by 12. So I'll divide this by 12, this by 12, and this by 12. So when I do that, I will end up with x plus 1, that quantity squared over 3, plus y minus 1, that quantity squared over 4 equals 1. So now I've got it in my standard form for the ellipse. So with that said, all right, so when I take a look at my coordinates for my center, I'm going to have -1, 1. So I'm going to go ahead and get that plotted. That's no big deal. Now when I analyze the 4 underneath my y minus 1 squared, since that's underneath the y minus 1, that tells me generally that my ellipse is going to be stretched vertically. So that's going to look like that, which means my major axis is going to go vertically. That's going to go up and down, which means that my foci are going to be on there, and so are my vertices. So the first thing I'm going to do is actually find my vertices, because that's pretty straightforward. When I take a look at 4, I'll square root that to get the value of a, and the square root of 4 is just 2. So that's going to be kind of nice. So what I'm going to do is from my center, I'm going to go 2 down and 1, 2 up. So I'm going to move 2 places up and down, and that's going to be kind of nice because then my coordinates for my vertices, that's pretty easy to see. That'll just be the coordinates -1, -1, as well as -1, and then 3. So that was pretty straightforward. That wasn't a big deal at all. Now when I take a look at my co-vertices, this one's a little bit trickier because here I've got to deal with my b value being the square root of 3. And that's not as nice. The square root of 3, that's kind of close to the square root of 4, which means that's kind of close to 2. Now for my co-vertices, I'm going to have -1 minus the square root of 3, which is going to be a little bit, that's going to get me to move left, and then I have -1 plus the square root of 3, and that's going to be to the right. So those are going to give me my the coordinates for my co-vertices, the exact coordinates for my co-vertices. It's not perfect, but that's pretty good. That's going to be pretty good. Now the last thing I need to find my foci. And in order to find the foci, I'm going to go ahead and set up my equation here. C squared equals a squared minus b squared. Well, c squared, to find that, I'm just going to simply plug in the a squared value. Well, that's 4. And the b squared value is 3. So the value of c squared is just going to be 1. And when I square root that, when I take plus or minus the square root of 1, I just get the value of 1. So that means from my center, I'm going to go 1 below and 1 above to get the coordinates or for my foci. So the foci, that's kind of nice because it works out to be integers. I'm going to have -1, 2, and -1, 0. So those are going to be the coordinates for my foci. So that's it for this example. Hopefully you're able to follow along. I like to look at things from that graphical piece because that really helps me kind of put a couple pieces together. So I totally encourage you to do that. Don't just look at everything from that algebraic perspective. Start to bring in a graphical piece. All right, and that'll help to make some things a little bit more clear for you. Thanks for watching this video, and I hope you guys have a great day. Peace out.